Today we shall study about the spectroscopy. Spectroscopy is the branch of science dealing with the study of interaction of electromagnetic radiation with matter. So it's a most powerful tool available for the study of atomic and molecular structures and is used in the analysis of a wide range of samples. Remember, spectroscopy is an instrumental technique used both for qualitative and quantitative study of the atomic and also the molecular structures. So it is based on two aspects. One is the electromagnetic radiation and the matter. So here we are studying the effect of interaction of electromagnetic radiation with matter. The basic principle involved here is when the electromagnetic radiation interacts with the matter, the outcome is the spectrum of samples containing atoms or the molecules. Usually, the spectrum is a graph where the intensity of the electromagnetic radiation either absorbed or emitted is plotted versus either frequency or the wavelength. Therefore, spectrometers are designed to measure the spectrum of a compound. There are mainly two types of spectroscopy. One is absorption spectroscopy and the one is emission spectroscopy. In case of absorption spectroscopy, the electromagnetic radiation is absorbed by the matter or the sample. Examples coming under this spectroscopy are UV visible spectroscopy, IR spectroscopy, etc. And the second one, emission spectroscopy. It is an analytical technique where the emission of either particle or radiation is studied with reference to some of the properties of the emission and amount of dispersion is measured. Example is mass spectroscopy. So why we have to study spectroscopy? Remember, it is a most powerful technique used in the study of atoms or molecules, and it is an important branch in research field. Without it, the study becomes incomplete. So now we shall see the advantages of spectroscopic techniques over the usual chemical methods for structure elucidation. Only a small amount of samples are required for the spectroscopic investigation. The spectroscopy techniques are highly reliable, very accurate, and the samples are required in micrograms. Generally, the sample remains unchanged in spectroscopic analysis and can be used further. So, you people are well versed with the chemical analysis. You have done the qualitative analysis in case of inorganic compounds and also in case of organic compounds, where you are utilizing so many chemicals for the knowing the structure or compounds. Afterwards, you are throwing all the reactants or the solutions into the sink. Means that much of chemicals are wasted in knowing simply the nature of the compounds. But in case of spectroscopic techniques, the samples remain unchanged even after the analysis. These techniques are much faster, highly reliable, most efficient, and sensitive than other chemical methods. Whatever the informations we are getting here are recorded in the form of permanent chart, and it is highly reliable in understanding the identity of two different compounds. Means, since whatever the data we are getting in spectroscopic analysis are in the form of graph, and that is why it is possible to preserve and also to compare the graphs for different compounds. By this way we can come to know the nature of the compounds, or we can establish the differences between two compounds. Continuous operation is possible, so this facilitates automatic process control in industries. With the help of spectroscopy, it is possible to study the reaction mechanisms, the intermediates formed in the reactions, the stereochemistry of the organic compounds, and also we can study the kinetics of the reactions. So with this, we shall move to understand the two words that we come across in spectroscopy. So as I told you, spectroscopy is the study of interaction of electromagnetic radiation with the matter. So we shall see first what is an electromagnetic radiation. So it consists of discrete packets of energy which are called as photons, and these photons consist of an oscillating electric field and also the magnetic field, which are perpendicular to each other, and the line of propagation is perpendicular to these two fields. So it is associated with different properties like wavelength. It's the distance between two successive crests or troughs. Then frequency is the number of waves passing through a given point in a unit time. It is denoted by nu, and wave number is defined as the number of waves per centimeter. So wave number is related to wavelength inversely. The relationship between wavelength and frequency can be written as nu frequency equal to c by lambda. Hence, a photon with energy E is given by an equation h nu, where h is a Planck's constant and nu is the frequency of radiation. So from this equation you can see that frequency is directly related to energy and wavelength is inversely related to the energy. Hence, as the frequency increases, the energy of the radiation increases. Lower the frequency, lower is the energy. While wavelength is inversely proportional to the energy, hence longer the wavelength, lower is the energy, shorter the wavelength, higher is the energy. Hence, the electromagnetic radiations are classified on the basis of a region of wavelength or frequency starting from higher frequency to the lower frequency, or from lower wavelength to higher wavelength. So this arrangement of electromagnetic radiation into different regions based on the frequency range or the wavelength range is called as electromagnetic radiation. So with reference to this, you can see here different names, like you already know gamma rays, as they are highly energetic and they have high frequency. Then comes X-ray. It can pass through the bones, which is used for the studying fractures or structures of the bones in humans. Then comes the UV radiation, which is very important for our study, where we will study the UV spectroscopy. Then comes IR radiation, which has lower energy than the UV and visible region. So then comes the microwave, radar, radio waves, etc. So the important ranges in the electromagnetic radiation we select here are UV range, visible range and the IR range. So that means in the electromagnetic radiation, electromagnetic spectrum, for the study of molecules, if we select UV range, then the spectroscopy is called as UV spectroscopy. Along with UV, sometimes visible range is also considered, then that is called as UV visible spectroscopy. If infrared radiation is selected for the study of molecules, then that part of spectroscopy is called as IR spectroscopy or infrared spectroscopy. So I repeat this once again. So in the electromagnetic spectrum, there are different ranges depending on the energy associated with each range. Among them, the important one are ultraviolet region, visible region. If these two ranges are selected for the study of molecules, then that spectroscopy is called as UV visible spectroscopy. And also if IR range is selected for the study of molecules, then it is called as IR spectroscopy. I think you have studied electromagnetic radiation in physical section also. Then we shall see what is the matter here. Matter is the substance which we want to study. So it includes the inorganic compounds, elements and also the organic compounds. Since the topic is in organic section, so matter here is organic molecules. Hence, in this topic we are studying the structures of organic molecules. Okay. So how it is possible to study the structure of molecules and what exactly is responsible for study of the organic molecules. So here we can see. So under the ordinary condition, molecules are in lowest energy levels. Let us denote it as E naught. So when the molecules absorb UV visible light, then this light, the UV visible light has enough energy to cause the excitation of electrons either in the bond pair or lone pair. So these electrons move to the higher energy level and this will cause electronic transition, and this transition can be represented with reference to energy as En minus E naught, where En is the nth energy level or different energy, higher energy levels, excited energy levels, E naught is the ground energy level, and this difference is equal to h nu. So this is the basis of the spectroscopy. That means when the light interacts with the molecules, light is nothing but electromagnetic radiation here. It has definite frequency or wavelength, and the energy levels are discrete, they are not continuous. Depending on the frequency of the light absorbed, the electrons will move from ground level to the higher energy level, and this is quantized and it requires definite energy. Hence, whatever the energy, the frequency is absorbed by the molecule, so we are plotting a graph of frequency absorbed, frequency versus the energy absorbed. So that is called as a spectrum. Similarly, the vibrational energy levels. These are quite less energetic than the electronic energy levels. Hence, they require the electromagnetic radiation with less energy. Hence, the infrared radiations, which have less energy than the UV radiation, when they are absorbed by the molecule is excited from one energy vibrational level to another vibrational level, and that is called as the IR spectroscopy. So, in all, in the UV visible region, the change that occurs is the electronic energy levels in the molecule, and we study here the conjugations in a molecule. So in case of IR radiation, we study the changes in the vibrational and rotational moment of the molecule. So by this we can detect different functional groups. Similarly, with the help of radio frequency, the changes in the magnetic properties around certain nuclei, and it is possible to study the different environments in a molecule. So these are the different spectroscopies that you are going to study. One is UV visible spectroscopy, where changes in the electronic energy levels are involved and conjugations in a molecule are predicted. Then IR spectroscopy, where changes in the vibrational and rotational moments of the molecules will be able to detect different functional groups. Then radio frequency is used in studying the different environments in a molecule. So, with this, I will conclude today's class. If you have any doubts, you can contact.